Hey guys, welcome back to the channel, and now in this video we will be understanding the Heisenberg's uncertainty principle. And trust me guys, if you watch this video till the end, then I assure you that you will be able to answer any question regarding to this principle. So according to de Broglie's hypothesis, microscopic particles possess wave nature as well as particle nature. Now, what is the meaning of this? De Broglie told us that all microscopic particles like your electron, proton, your neutrons, atoms, they will sometimes act like a wave and sometimes they will act like a particle, which means that they possess both wave nature as well as particle nature. Now guys, if you want to know in depth about the de Broglie hypothesis, then I have made a video. You can find the link in the description box below, or you can simply click on this I button over here. Now since the microscopic particles possess wave nature and particle nature, it was not possible to determine two things. What are those two things? Let's understand the first one. That is position and momentum simultaneously. Suppose your microscopic particle is an electron, and as we all know that electron is continuously moving. So you cannot calculate the position of an electron and the momentum of an electron at the same time. And even if you calculate position and momentum at the same time, then there will surely be an error in the position and momentum as well. So, and the second thing that was not possible to determine was that position and velocity simultaneously, which means that you cannot calculate the position of an electron and the velocity of an electron at the same instant of time. So here comes Werner Heisenberg, a German physicist who proposed a principle in 1927. And what is that principle? Let's understand that. He said that it is not possible to determine simultaneously the position and momentum of a moving microscopic particle with absolute accuracy. This is what we have seen, that you cannot calculate the position and momentum of a microscopic particle which is moving at the same instant of time, that is simultaneously. So you might be wondering what is the new he told to us. He told us further that suppose delta x is uncertainty in the determination of the position, which means that suppose you calculated the position, and as we all know that there will be some error in the position. Okay, so let's say delta x is the error. Uncertainty means what? Simply error in the determination of the position. And let's say delta p is what? Error in the moment determination of momentum. So I hope these two terms are clear. Delta x is nothing but error in the determination of position, and delta p is nothing but error in the determination of momentum. And he gave us a wonderful equation which is delta x into delta p will be greater than or equals to h upon 4 pi. Now what is the meaning of this? He said that when you will multiply the uncertainty in position with uncertainty in momentum, then the multiplication will be equal to h upon 4 pi or greater than that, where this h is nothing but Planck's constant, and as we all know that the value of this Planck's constant is nothing but 6.62 into 10 raised to minus 34 joules second. Now moving ahead, I will just consider this equation again. Okay, Now in this equation, what is this P? This P is nothing but momentum. Am I right? And as we all know that the formula for momentum, P is nothing but equals to mass into velocity. So can I substitute this mass into velocity in this equation? So this is what I am going to do now. I am just substituting mass into velocity in place of P. But here if you observe carefully in this formula, mass into velocity. What is this mass? Let's say this our microscopic particle is electron. So this m is nothing but mass of an electron, and this v is nothing but velocity of an electron. But guys, you all know that the mass of an electron is always fixed. That is 9.1 into 10 raised to minus 31 kg. Is the mass of an electron going to change? No. The mass of an electron is not going to change. So how can there be an error in the mass of an electron? So how can there be delta m? So since there is no error in m, so what I am going to do is I will just shift this m from left hand side to right hand side. So when it goes on the right hand side, it is obviously going to go into the denominator. Now what does this equation mean? In this equation, this delta V is nothing but uncertainty in the determination of velocity. So this equation tells us that suppose you multiply the uncertainty in position with the uncertainty in velocity, the multiplication will be equals to h upon 4m pi, or it will be greater than that. I hope you guys know what is the meaning of this, which is greater than or equals to. Okay, so I hope you all understood. This equation is for the condition where you calculate position and momentum simultaneously, and this equation is for the condition when you calculate position and velocity simultaneously. So if you all remember, in the starting of the video I said that there are two problems to determine. That is, we cannot determine two things. The first one is position along with momentum, and the second one is position along with your velocity. So here we have taken the errors of position and multiplied with the error of momentum, and here we have taken the error of position and multiplied with the error of velocity. So I hope for you guys these two equations are pretty much clear. Okay, so now moving ahead, let's understand a simple numerical so that your concept gets crystal clear. Okay, so in this numerical, it is told to us to calculate the uncertainty in the position of electron if the uncertainty in its velocity is 5.7 into 10 raised to 5 meters per second. So if you read this question carefully, we are being told to calculate the uncertainty in the position, which means that we are being told to calculate it delta x. So we want to find out what is the value of delta x, and what is given to us. Uncertainty in its velocity is 5.7 into 10 raised to 5 meters per second, which means that can I say delta v is given to us. That is, error in velocity is given to us. That is 5.7 into 10 raised to 5 meters per second. Now, since in the question it is already being mentioned, it is an electron. Am I right? So I will take the mass of an electron, which is nothing but 9.1 into 10 raised to minus 31 kg. Am I right? And one more thing that we all know is the value of h. And what is h? H is nothing but Planck's constant, and its value is nothing but 6.62 into 10 raised to minus 34 joules second. Okay. Now, with the help of the equation given to us by Heisenberg, and what is that equation? delta x into delta v is equals to h upon 4 m pi. Now you might take an objection that I have not written greater than or equals to. See, that greater than or equals to is only applicable when you don't know the value of x as well as you don't know the value of v. But suppose you know value of any one of that, then you have to simply write equals to. Okay. So here while solving numericals, just keep in mind you have to write equal to. Okay. Now just since I want to find out delta x, what I will do, I will shift this delta v to the right hand side, and when it goes to the right hand side, it is obviously be going in the denominator. And now the job is simple, that is we just have to substitute the values of the respective terms, and that is what I have done. See, I have substituted the value of h as 6.62 into 10 raised to minus 34 divided by 4 into mass of an electron into pi value, that is 3.142 into 5.7 into 10 raised to 5, which is nothing but a delta v as written above. And the delta x value you get is 10 raised to minus 10 meter. So guys, this was all about your Heisenberg's uncertainty principle. Do check out my channel where I uploaded chemistry and physics videos. They might be helpful for you all. And guys, please don't forget to subscribe to the channel. Okay, so guys, thanks for watching this video. And if you have any doubts, do comment below.